Hello everyone, welcome back to Analytical Chemistry class, and today we are on the stoichiometric calculations. Okay, let me just mention to you, why do you need to learn stoichiometric calculation? When you go to lab, most of the time you're just going to make some measurement, right? So we measure something, and then we are going to use the stoichiometric concept, okay, for us to do some calculation and obtain the information needed. Only then we can make conclusion or make sense of the results that we have. Now, in this blended learning, we are going to look into the first two parts of the stoichiometric calculation. Now, let us look into the subtopic 3.1 on the review of fundamental concepts. This is going to be some kind of just a recap of general chemistry that you have learned during your foundation, diploma, or your A-level studies. Okay, so what is stoichiometry? Okay, so stoichiometry is the study of quantitative relationship. We are talking about numbers here, okay, between chemical formula and balanced chemical equation. So it is really important that I would expect you to know how to balance chemical equations, all right, and how to write the chemical formula. All right, so and then if we want to perform stoichiometric calculations, there are several basic parts that we need to review and look. For example, the mass of particles, the mole concept, the molar mass, and also how you interconvert between this analysis. What are the purpose of stoichiometry in analytical chemistry? The first one is for you to determine how much reactant do you need in a reactions, okay, or in an experiment. Secondly is for you to calculate or determine the amount of product that can be formed, okay, and then you can use it to design the analytical methods, and lastly for you to convert between one properties to another properties. All right, okay, I would like to highlight to you about mass and weight. Okay, so in chemistry, or at least in this analytical chemistry subject, okay, most of the time the chemical calculations that we use here is performed on Earth. So sometimes I will just use the word mass and weight interchangeably. All right, so that is the assumption here. Okay. Now, the first part of the review that we are going to look is into the difference between atomic mass, molecular mass, and also formula mass. Okay, so these are all mass of particles, like all the small particles. Okay, so for example, you have average atomic mass, or sometimes we just call atomic mass. Okay, and this is basically a mass of an atom. Okay, and this is already the one that we consider about the natural abundance, okay, of the isotopes. For example, the carbon atom has an atomic mass of 12.01 AMU. So we can consider like a single carbon atom is going to have a mass of around 12.01 AMU. Okay, and then molecular mass. Molecular mass is just a the sum of atomic mass of molecules or molecular compounds. Okay, for example, if you have water is made up of 2 hydrogen atoms and 1 oxygen atoms. So when they combine together, okay, they are going to form molecules. So the mass of this molecule is what we call as the molecular mass. All right, last but not least, we also have formula mass. Okay, so formula mass is actually the sum of atomic mass as well, but we are talking about ionic compound. However, all right, so in laboratory measurement, we do not deal with something like small atoms, all right, but we deal with the macroscopic amount. So most of the time we need to use moles instead of these AMU units. Right, now the question is, what is moles? Okay, so now we are going to look into the second subtopic, okay, which is on moles and molar mass. Okay, so what is a mole? Okay, I hope you know by now. All right, so mole is actually just like a dozen. Okay, so if I say that I have 1 dozen of carbon atoms, what do I mean? Meaning to say I have 12 carbon atoms. If I say like I have a pair of carbon atoms, meaning to say I have 2 carbon atoms, right? But when I say I have 1 mole of carbon atoms, what does it mean? It means that I have 6.02 exponent 23 carbon atoms. And that's a lot, right? So this number, okay, is what we call as the Avogadro's number. And then what is molar mass? We have looked into what is atomic mass, we look into moles, and then now what is molar mass? Okay, all right, so molar mass is actually the mass of 1 mole of substance. For example, if I have 1 carbon atom, the mass is 12 AMU. If I have 2 carbon atoms, the mass is going to be 24 AMU, right? If I have 10 carbon atoms, I'm going to have 120 around that, okay, AMU. Okay, but what if I have 6.02, okay, which is 1 mole, 6.02 exponent 23 carbon atoms. Okay, so the mass is going to be a very big number if we were to express in AMU. So we can express this in the unit of gram per mole. So actually, the molar mass has the same value in terms of the numbers as the one to the atomic mass that you found on periodic table. Okay, but the definition, the concept is just that it's based on this Avogadro's number. So that if people ask you what are the difference between atomic mass and molar mass, you should be able to answer that as a chemist, alright? So actually, going from mass of a substance that we measure in the lab, okay, we can convert into, okay, how many moles are there? Okay, and then we can convert from the moles, we can convert into how many particles are there. Alright? So, this is the whole dimensional analysis. So, you can go from mass to mole and then from mole to number of particles. So, you just need to know the formula that you have to use for you to go from one point to another point. So, that's it for part 1. Let me just ask you a quick questions about this exercise. Maybe you can pause this video and try the first 3 questions or the first question. So for this question, it asks you, calculate the number of moles in 500 milligrams sodium tungstate. That is the formula. Alright. Given is the mass, so you want to find the mole. So we know that the moles can be found from this formula. Mole equals to mass divided by molar mass. Okay, so what is your answer? So did you get the same answer? The answer is 1.701 millimole. Let me just mention to you here that if you have gram per mole, okay, the unit is just similar to milligram per millimole. So in my final answer, I answer it as 1.7 millimole. Right. The second question, okay, you have the mole. Now you need to know how to calculate the mass, right? So you just manipulate the formula to become mass equals to mole times molar mass. What's your answer here? Your answer, is it the same as me? So I get it to be 39.925 millimole. Sorry. Oh, this is incorrect. Okay, should be milligram. So always check at the unit conversion. So here millimole will cancel with millimole. So you are left with milligram. So you go straight to milligram. Now, the last question, a solution of glucose contains 1.2 exponent 22 particles. Calculate the mass of glucose. Right, that's the answer. Did you get? The mass is 3.59 gram. So this one, you need to move 2 sides. Okay, for example, here, okay, you are given the number of particles. So you need to calculate the mole first, and then you can calculate the mass. Alright, so in my case here, I just calculate everything in one go. It really depends on how comfortable you are in calculating things. Alright. Okay, maybe you want to take a deep breath, and then we are going to go to part 3.2 here. Are we good? Okay, so now in analytical chemistry, you are going to deal a lot with solutions, okay, especially liquid solutions. So you need to know how the concentration are being expressed, okay. Okay, so first, before we move into the concentration of solutions, let me just bring you back, okay, and recap a little about what is a solution. All right, so a solution is formed when one substance disperses uniformly throughout another. Okay, for example, you can have a solution like this. Okay, a solution is made up of solute and also solvent, right? Okay, so you need to know how to differentiate between which one is solute, which one is solvent. Okay. Okay, so concentrations. So this solution, like we want to know how much is there. Okay, how concentrated the solution is. So we can use the concentration units. So concentration, okay, they are used to I'm sorry. Hello, can you please go away? Baby. Right. Okay. Right. Where were we? Okay. Concentration. So now you want to know how concentrated a solution is. So we can know this through the concentration unit, and you can express the amount of solute dissolved in each quantity of solvent or solution. So basically, concentration is just amount of solute divided by the amount of solvent or solution. And when we talk about amount, it can be mass, it can be mole, it can be volume, all right? Okay, anything about amount. Amount is quite general. So, how can you express the concentrations in this subtopic? Okay, we are going to look into 6 ways of expressing concentrations. The first one, the most famous one, is molarity, right? So, molarity is used to measure the amount of solute in a particle volume of solution. Let's say I dissolve this amount or this gram of something in a solution, okay? So you should be able to move from mass to mole, from mole to molarity, or the other way around. All right? Now, I just would like to mention to you that molarity is temperature dependent. So if the temperature varies, so likely the molarity value will vary as well, because the volume will vary with temperature. Now, and then we can have these types of molarity. You can have either analytical molarity or species molarity. Let me just show this quickly. Species molarity, okay, is used to express the molar concentration of particular species in a solution at equilibrium. Okay, especially this is useful when we are talking about the electrolyte. So when you dissolve an electrolyte, okay, they will dissociate into its particular species. For example, you have calcium chloride. You dissolve some amount of calcium chloride into water. So the concentration of calcium chloride that you dissolve is 0.5 molarity, for example. So this is what we call as analytical molarity. But then, okay, when the calcium chloride is dissolved in water, they are going to dissociate, all right? Now, they are going to dissociate into, for example, calcium ion and 2 chloride ion, right? So, the concentration, the analytical molarity is 0.5 molar, okay? But the species molarity of calcium is also 0.5. But what about the species molarity of chloride ion? Is going to be 2 times 0.5. Why? Because when you have one calcium chloride, okay, when they dissociate, okay, they are going to form 2 chloride ions. All right? So I hope that you are able to differentiate between analytical and species molarity. Alright, so let me just mention to you here about formality. Okay, operationally, this analytical molarity is what we call as formality. But I would say that this is just the old school way of like for us to like be pedantic or for us to be clear about dissociation, right? But for convenience in this course, okay, we will use molarity exclusively. Therefore, this part is just an extra information. So let me just mention to you, formality is just analytical molarity. All right, so you can read this through. All right, so in this case, sometimes, okay, you just now I said this is analytical molarity, but you can also call this as formality. So if I ask you, what is the formality of calcium chloride solution here? The formality is 0.5 formal, right? Instead of you say 0.5 molar. Okay, they are the same. Okay, and then we are going to look into the second part, which is also an extra info. Okay, so this is normality. What is normality? Normality is actually a solution expression of concentration as well. Okay, but we are looking into the number of equivalents. Equivalent, all right, is the amount of reactive substance, okay, that is going to react in the reactions. So you just need to know, for example, you have acid and base. Okay, so what is the equivalent? Okay, the amount, the reactive substance. The reactive substance is H plus in the acid, and in base it's OH minus. If I say like I have 1 molar HCl, it means that I have 1 normality, right? 1 normality of HCl. Okay, or this sulfuric acid has 2 normality. Okay, the sulfuric acid concentration is 2 normality, meaning to say that the sulfuric acid molarity is 1 molarity. Why? Because in H2SO4 it has 2 equivalent, okay, 2 reactive units. So it's just that 2 times the molarity concentration. Alright, okay, but as I mentioned also, in this case, in the calculations, whatever that is coming next, we are just going to use molarity exclusively. Okay, next one, molality. Molality is the mole of solute divided by mass of solvent in kilogram. Alright, just like molarity, molarity is mole of solute divided by liter of solution, right? But this one you just divide by mass of solvent. Okay, so why do we need to have this molality? Is it just to confuse you? Okay, of course not. Okay, because molality is independent of temperature, so it's quite easy and it is very useful when we talk about colligative properties. All right, and then we also have what we call as the percent concentration or fraction concentration. All right, and this percent or fraction can be by mass, by volume, or by mole. All right, for example, you can have mass percent, volume percent, mass over volume percent, and mole percent. Okay, so the definition you can read this through, but I would like to just look into the formula. Okay, when I say mass percent, sometimes it is labeled as percent weight by weight. Okay, meaning to say this is the weight of solute divided by weight of solution, or the mass of solute divided by mass of solution. Okay, anything that is divided is what we call as the fraction. Sometimes it can be in fraction or sometimes it can be in percent. So in percent is just you times by 100%, right? Of course, this unit, they can have some kind of disadvantage, which is they can can be source of ambiguity. Sometimes people just write percent. They did not mention, is it a weight percent, is it a volume percent, is it a mass of a volume percent, or is it mole percent. So when we write, we need to make sure we are clear on that. Now, last but not least, the type of concentration is trace concentration unit. So what is trace concentration? Trace concentration, we use this, okay, for something that is very, very dilute. This is quite common in analytical chemistry. So the units can be parts per thousand, can be parts per million, or can be parts per billion. But the one that is more common is just parts per million and parts per billion. All right. Okay. So here, ppm, ppb, they are just like a how do you divide the solute in a solution. All right, and it have the ratio. For example, for million, the ratio is by power 6. Okay, but for billion, the ratio is by power 9. So 1 ppm, for example, is equals to, okay, sometimes the ppm can also be 1 milligram per kilogram, right? Look at that. The ratio is also 10 power 6, okay? And then the ppb can be 1 microgram divided by kilogram. That is 1 ppb, okay? So you can choose which one is more suitable. Okay, we can look into example. When we are talking about interconverting between quantities, for example, earlier you have mass, you have mole, but now we have molarity. So you need to know how to calculate all this, and also how you interchange between other species, and also how you interchange the units. Okay, so this is really, really important. Okay, because sometimes we give you in one unit, but you need to solve in another unit. So you must be really handful in the calculations related to unit of concentration conversion. Okay, all right. So let me just mention to you, if you want to interconvert units, sometimes you need to have this extra information. For example, usually is density. Okay, so you need to know the density of solution is equal to mass of solution, okay, divided by the volume of the solution. All right, so if you want to be successful, okay, you need to always ask yourself, okay, this is a tips, like, okay, what do I have? What unit do I have? And then the second, what is the unit that I need? You need to ask yourself. And then, so how do I go from what I have to what I need? And then you can map yourself out. Do not panic. All right. In different sample, we have different concentration unit that is appropriate. You will know more as you experience, as you go to lab, you look at chemical labels, okay, you read articles, and then you will see that, oh, this is in this sample people use ppm, in this sample people use molarity, in this kind of sample people use percentage. Okay, all right, now let us look quickly into these exercises. All right, the one that is given to you is microgram. Okay, microgram, the unit is already 10 power 6. This one is already in 1, right? So the ratio is already in ppm. So you just need to divide the number and you get it to be 1.38 ppm. Okay, so now from ppm for you to convert into ppb, because you go from 10 power 6, you want to go to 10 power 9. Okay, so you just times by 1000, which you will get around 1380 ppb. All right, now the second question here. Okay, so the answer is 0.2 molarity. All right, second question, assuming complete dissociation, calculate the species molarity in the solution. Okay, question number 3. A nitric acid solution contains 4250 ppm nitric acid by mass, okay, in water. The density of the solution is that. Now calculate the molarity. So you have from ppm, okay, you want to convert into molarity. Okay, you can have 3 kind of units for ppm. For example, microgram per gram, milligram per liter, or milligram per kilogram, or microlit 2 over 1 liter. Okay, so which of these you are going to pick? Okay. Alright, so that is a really great answer, in which we are going to just pick milligram per liter because it's going to be easier. You go from milligram per liter, you want to convert into mole per liter. Your answer, so interesting because you get it to be 0.067. Okay, so from there you can calculate the molality of the solution, okay, as seen here. Alright, so the last part here, I'm not going to give you the answer because I want you to answer this as part of the quiz. So let me just try to wait for you to answer this. So I guess that's it for our first part of the video here on the blended learning. So all the best. Keep on looking into exercises for you to do and do more practices if you think that you do not master on this stoichiometry part yet. Alright, all the best.